In the next few sections, we're going to start studying different characteristics of triangles, so hopefully a lot of this will seem familiar from your geometry classes. Here I'm just reminding you of a few important properties. In case you've forgotten these, the angles in a triangle add up to 180. So this is going to be very useful. If you know two of the angles in a triangle, then don't forget you can just take those two and subtract them from 180 to find the third missing angle. Also, don't forget that ratio-wise, the smallest angle is going to be opposite or across from the smallest side. So when you look at any angle in a triangle, and I'll show you that on the next slide, the two sides touching it would not be the ones across from. You're looking at the one that's not touching that specific angle. And one common mistake I see a lot of people make is they try to use the Pythagorean theorem for all triangles, but that only works for right triangles, which have a 90-degree angle in them somewhere. In the first section, we're going to study something called law of sines, and there are several cases of this. First, we're going to talk about the case where they give you two angles and a side, and that side may be one of the random sides not related to either of the angles, or it may be the side in between the two angles that you're given. One comment I'd like to make about this ratio is it actually doesn't matter if you flip everything upside down on these. If you take the reciprocal of all three fractions, it'll still work. So you can say side A over sine of angle A, side B over sine of angle B, etc. So the capital letters represent the angle measurements inside the triangle, and the lowercase letters represent the sides opposite those. So for angle A, for example, there's a side touching it here and a side touching it here. We're talking about the side that is directly across from it when I'm saying side A compared to angle A. In the first example I'm going to work out here, you can see that we have an angle A, an angle C, and then a side C. And again, that's coming from the fact that capital letters are angles and lowercase letters are sides, but you can also tell because of the degree symbols that they have specified on these. So since this last one doesn't have a degree symbol, you know it has to be a side length. And usually there will be some kind of a unit specified. In this case, it's 56 inches. So that's also a hint that this is a side length instead. So for solving this triangle, I have side C and the angle across from it. So side C is 56, angle C is 63. So if you're looking at the formulas, we can write sine of 63 divided by the side, 56, and that would be equal to sine of the angle, 46, and I don't actually know what side A is. That information wasn't given to us. So it's one of the things we're looking for. Now you'll notice that I never did anything with angle or side B in this formula. In general, you're only going to be picking two of these three pieces at a time. So right now I'm ignoring the middle piece and I'm just setting the first piece equal to the last piece, and then I'm going to cross multiply. Some people have been cross multiplying at the wrong times. You can only do that when you have an equal sign in between the two fractions. It does not work when you are multiplying two fractions together on the same side of an equation. So my next step here would be to write A times sine of 63 equals 56 times sine of 46. And then since the opposite of multiplying by sine of 63 is dividing by sine of 63, my missing side would come from 56 sine 46 divided by sine of 63. And let me also strongly encourage you to make sure that your calculators are in degree mode for this. We know that they're degree measurements because they have the degree symbols on there. So you don't want to get the wrong answers by having your calculator in radian mode. Plugging this into my calculator, I'm getting a value of 45.2 inches. Notice the directions do say round to the nearest tenth. So right now we know two of the sides of the triangle, side A, side C, and we know two of the angles, angle A and angle C. And remember, I also mentioned that you can always find the missing angle, in this case B, by doing 180 minus the two that you know. So in this case, you should be getting that angle B is equal to 71. And now that we have that missing piece of information, we can use the formula again for law of sines. This time I'm going to be setting the information from C equal to the information from B. I always recommend when you're picking which sides and angles to use going for the last missing values, that you use the ones from the original problem that had both pieces filled in, because there were some rounding issues on this one. It wasn't exactly 45.2, it was actually like 45.21070017, but from the given information, I can assume that these were exactly 56 and 63 degrees. So I'm going to say sine of 71, and we don't know side B, we're going to look for that one. And then again, I want to use the one that we have very accurate numbers for, so I'm going to use the C values. So again, cross multiply on this. So you should get 56 sine of 71, and then B times sine of 63. And then when you divide both sides by sine of 63, if you put this one in your calculator, 56 times sine of 71, and divide that by sine of 63, I'm getting 59.4. And it is a good idea for you to practice plugging those into your own calculator just to make sure that you're not making a mistake with your rounding or with how you're using parentheses to plug those in, so that when you go to do some on your own, you're getting the same answers that I am. It's not really a big deal, but since we did round these answers, I like to use the approximately. It looks like an equal symbol, but it's a little wavier just to indicate that I did do some rounding on these answers. It was not exactly 59.4. This next example is pretty similar, honestly, but you'll notice that this time I don't have any of my angle and side pairs. I have angle A, angle C, and side B. So I don't have any of the pairs set, which means my first step has to be finding the missing angle. Since I know two of them, I can do 180 minus the two that I know, which is going to give me 96.5 degrees. Now that I have one angle side pair, because we know that side B is 76 miles, I can start working with sine of 96.5 and side B, which is 76, and then pick whichever one you want to set equal to first. It's not really going to matter in the long run here. So you can solve for side A or for side C, whichever one you prefer. So I'm going to do sine of 50, and then that will be side A. Do be careful about your labeling, because when you're on a test question, I will be having the blanks filled out as what is angle A, what is side A. So if you mix and match a little bit, you would get points off for that. So I'm going to cross multiply. This would be A sine of 96.5 equals 76 times sine of 50. And then if you want to skip showing the next step where I'm just dividing by 96.5, that's okay. So in your calculator, you'll hit 76 times sine of 50, and you'll divide that by sine of 96.5 in this case. Be careful with your parentheses use. I'm getting approximately 58.6. And that would be the same unit, so it should still be in terms of miles. And then now we know all three angles, we know two of the sides, we still have to find one more. So make sure you end up with 6 answers altogether. There should be the 3 that you're given and then 3 that you solve for. So in this case, I still need to find what side C is. I'm going to go back to using the most precise values that I have, which would be the angle B relationship. And we already solved for A, so now we're going to solve for side C, which is based on the angle 33.5. So cross multiply again. And then you're just plugging this into your calculator. So 76 times sine of 33.5 divided by sine of 96.5. My answer was approximately 42.2 miles again. And so that's it. That's all of the values we needed for this triangle. Whenever they say solve for the triangle, that's what they mean. Find all of the missing values. That's all for the notes. Thank you, guys.